So let's look at a sample question. The turbine and its associated rotating parts of a jet engine have a total moment of inertia of 25 kg/m squared. It is accelerated uniformly from rest to an angular speed of 150 radians per second in a time of 25 seconds. Find the angular acceleration, the net torque required, the angle turned through during the acceleration, work done by the net torque, and finally the kinetic energy of the turbine at its final velocity. Let's firstly look at the angular acceleration. Angular acceleration is alpha equals the change of theta, the change of angular velocity, over the change of time. In this case, our change in angular velocity would be 150 minus 0, final minus initial, over time 25 seconds, which would give us 6 radians per second squared. Now, having found the angular acceleration, we can look at the net torque required. The net torque required would be torque equals moment of inertia times angular acceleration. In this case, that will be 25 kg/m² times 6 for the acceleration, which would give us 150 Nm for the torque. Now, let's look at the angle turned through during the acceleration. In order to be able to find the angle, we need to use a formula. In this case, theta final squared, omega final squared equals omega initial squared plus 2 alpha delta theta would give us the angle theta, since we know all the other factors in the formula. In this problem, that would be 150 squared equals 0 squared plus 2 times 6 times delta omega. From this we could find delta omega with the by dividing 22,500 by 12, which would give us 1,875 radians. Now, for part D, we need to find the work done by the net torque. Work done would be net torque times the angle, which is basically displacement, distance for angular motion. That will be 150 times 1,875, which would equal to... Evet.
Was that correct?
Evet.
Hani panik